Okay, guys, so here's part 2 for our elevation and depression notes. Again, like I said, we're just going to take a look at a few more examples, practice setting up those pictures. On any of these slides, feel free to hit pause, do the problem yourself, come back, hit play, and then watch me do the whole process. So number 1 here says a kite is flying at an angle of elevation of 40 degrees. All 80 meters of string have been let out. Find the height of the kite. So first thing, triangle, told me elevation, so I do want to keep it here with my right angle at the bottom, right? Okay, it says it's flying at an angle of elevation of 40 degrees. So I actually know my angle of elevation down here is 40. All 80 meters of string have been let out, and find the height of the kite. So I have an 80 and I have an X that need to go somewhere. Think about what happens when you fly a kite. When you fly a kite, the kite is up in the air somewhere, but you want to think about what the string does. A kite doesn't float right above your head like a balloon does. A kite has to be at an angle because the wind is blowing it. So this should be my 80 meters of string. It also says find the height, and we should understand that in a triangle, our height has to be going straight up and down. It has to make the right angle. So even if I tried to put my 80 meters of string on the left, then the question would be, well, where's the height, right? Height doesn't make sense on the ground. It really doesn't make sense measuring it on an angle. So that would also be a key thing of I need to maybe rework where things are. So right angle, I go across, here's my hypotenuse. 40-degree angle, I go across, here's my opposite. In this case, adjacent is empty. So opposite and hypotenuse, that's going to be sine. 40 degrees equals opposite over hypotenuse, x over 80. Multiply both sides by 80. 80 sine of 40, that's going to be our value for x. So again, use your calculator. 80 times the sine of 40 is a 51.4. In this case, we need meters for x. There's our answer to question 1. Question 2, a blimp hovers over a stadium at an altitude of 125 meters. The pilot sights a tennis court at an 8-degree angle of depression. Find the ground distance in a straight line between the stadium and the tennis court. So first thing I need is my triangle. This time they did tell me angle of depression, so I'm going to flip her upside down. Let's put my right angle in here. Okay, and then we need to put in what they told me. Okay, they told me an altitude of 125 meters, and they told me an 8-degree angle of depression, and obviously I have an x that I'm finding. So first thing I know is I can slide my 8-degree angle into place. Altitude, remember, an altitude is how high something is. We measure height straight up and down. Find the ground distance. Well, where's the ground in a picture like this? The ground would be down here. Again, how I measure horizontally is the same on the ground as it would be in the sky. The idea is the blimp is hovering over one item, and then over here is the other. So how far apart are they? So in this case, hypotenuse is empty. Here's my opposite. That makes this adjacent. So I am looking at the tangent of 8 equaling my fraction opposite 125 over adjacent, which is x. So again, multiply both sides by x, divide both sides by the tangent of 8, and you're going to end up with 125 over the tangent of 8, and that's what needs to go into a calculator. Just make sure you're entering things carefully. Remember, if yours is a calculator where you need to put numbers in before the word, make sure we're doing that. In this case, our x is going to equal 889.4, and once again, this was measured in meters. So make sure we are putting a unit since we are talking a word problem. And there's our answer for number 2. Let's do one more. The back bumper of a truck is 3.5 feet off of the ground. A loading ramp attached to the back bumper has an incline of 10 degrees. How long is the ramp? So this is the only question we've looked at that doesn't use the word elevation or depression. And I will say 90% or more of the problems would probably use one of those two keywords. In this case, our keyword here is actually incline. Think about what that might mean. Anytime you're talking about a triangle or something that is slanted, an incline is an angle of elevation. It's how much has that angle increased from being flat on the ground. Okay. So if this is my triangle, okay, it says that the back bumper of a truck is 3.5 feet off the ground. Loading ramp has an incline of 10 degrees, and we're going to have our X, right? So incline of 10 degrees, 3.5 feet off the ground. So ground, we go up 3.5 feet. How long is the ramp? Well, is a ramp flat on the ground or is a ramp slanted? A ramp is slanted. So I want the slanted side. I want the ramp. So in this case, I have a hypotenuse. I have my opposite and my adjacent is empty. So this means I get to use sine. Sine of 10 equals opposite over hypotenuse. Again, multiply by x. In this case, divide by sine of 10. Show those steps if that's helpful to you. There we go. So I need to put 3.5 divided by sine 10 into my calculator. In this case, I'm going to get a 20.2 when I round to, and this was measured in feet. And so there is our answer for number 3.